So, good afternoon, students. And uh, in last two classes, we were not able to take up the lecture because there was some electricity issue in my room. So now it has been corrected, and today we have done one more enhancement that I think so. You can give me the feedback after this lecture. Today I'm using one mic also, so that you will not be facing much difficulty in the voice issue, because in earlier our these lectures we were facing some of the voice issues. Okay, so with this enhancement I think now the voice will be much more clear as compared to the previous videos. Okay, so we have already completed with the hypothesis part. Okay, what is hypothesis, how to test it, and what is type 1 and type 2 errors. Okay, so today we are actually going to do some of the tests, and in this series the first will be Z test. Okay, so in this Z test we will be starting. Okay, so starting with the introduction. In the previous lecture, we have defined the basic terms regarding the testing of hypothesis. Okay, and to cover up the syllabus which were left in the last two classes, we will be having the two sessions today. And I think in two sessions we will be completing this jet test, and from tomorrow we will be starting with the t test. Okay, so after providing you the necessary material required for any test, now we can move towards discussing particular test one by one. Okay, so these tests can be categorized as large sample test. This is the main point. Okay, what is a Z test? Z test is also known as large sample test. Okay, and there are some small sample test which includes t test. So we will not be discussing this small sample test as for now. Okay, so we will be taking it up in next lecture. Okay, so what happens that sometimes in our studies in the field of whether it is economics, psychology, medical, or this veterinary, etc., we take a sample of objects or particular units or participants or patients, etc., such as they may constitute around 70 observations or 500 or 1000 participants, or sometimes 10,000 participants, like this. Okay, so this situation comes under the category of large samples. Okay, whether they are 70, 500, 1000, 10,000. So how to make a this cutoff, that which is a small sample and which is a large sample. Okay, so what is that thumb rule? So as a thumb rule, okay, a sample of size n is treated as a large sample only if it contains more than 30 units. That is, it should have the observations, the number of observations should be greater than 30. Then it is said to be large sample. And we know that for large samples, that is n greater than 30, one statistical fact is almost all sampling distribution of the statistics closely approximated by the normal distribution. That is, when you will be having a sample size of greater than 30, so your this sample statistics will approximately follows the normal distribution. Okay, so therefore test statistics, which is a function of sample observation based on n greater than 30, could be assumed to follow the normal distribution approximately or exactly. Okay, so whatever the laws governing the normal distribution will be there, will be applied to these tests on the large sample. Okay, and what are those things? We have already studied in the normal distribution that we have a Z table. Okay, so that table will be included in this test also. Okay, now we will start our hypothesis testing for large sample. Okay, so as we have already described in our previous lecture, that in this previous section right now, that for a large sample size, when n is greater than 30, One statistical fact is that almost all sampling distribution of the statistics closely approximated by the normal distribution. Okay. Therefore, when the sample size is large, one can apply the normal distribution based test procedures. Okay. What you can do? You can apply the normal distribution based test procedures to test the hypothesis, whatever hypothesis a researcher is making. Okay. So in previous lecture we have been given the procedure of testing the hypothesis in general. Okay. Now let us now discuss the procedure of testing hypothesis for large samples in particular. So in this particular lecture we will be discussing the testing of hypothesis for large samples. Okay. So commonly used, there are some commonly used cutoff values which are used for this hypothesis testing of large samples. Okay. And these I must designate this as table 1. Okay. This is table 1, and what it represents, the cutoff values. Okay. That is critical cutoff values for Z test. So when, say for example, there is let me bring this to the one. So say for example, we have different level of significance. We have already studied about the type 1 error and type 2 error. Okay. And we have studied about the level of significance alpha. So here we will be testing our test at 5% level of significance and 1% level of significance. These are commonly used level of significance for testing the hypothesis. Okay. Now, say for example, what I am showing in this table is that the Z test can be of two types. Okay. One, it can be two-tail test. Other, it can be one-tail test. In case of one-tail test, it can be right-tailed or it can be left-tailed. Okay. If the value of Z resides on the left side, that is on the minus value, so it will be left-tailed test. If it is on resides on the right side, so it will be known as right tail test. Okay. So because today I am using this mic, so if you face any difficulty still in this uh, voice, so you can write in the live chat box. Okay. So basically, in two-tailed test, the value of z can assume the values from plus to minus. Okay. So this I have shown in the figures. That is, for two-tailed test, if we take the level of significance 5%, so our value of z spans from plus 1.96 to minus 1.96. If we take the level of significance 1%, then our Z value spans from minus 2.58 to plus 2.58. Similarly, if we take one tail test and level of significance as 5%, so our Z value will span from up to 1.645 from the right side. And if it is on the left, then it will be from left most corner to up to the minus 1.645. So this thing can more be appreciated in the figures. Okay. So let me tell you now. So this one is the figure 1. When there is 5% level of significance, so your this Z value, okay, your Z value spans from minus 1.6 to plus 1.6. Say for example, if I make a normal distribution and this is the highest point, and in case of Z table we have already studied that the mean of this normal variate is 0 and it has a standard deviation equal to 1, isn't it? So it will be 1, it will be 2, it will be 3, like this. On this side also it will be 1, 2, 3 like this. Okay, so this 1.96 will somewhere lie here. Okay, so this will be 1.96 minus. On the left side it is minus values. Okay, I must make it minus, and on the right side these are plus values. So this will lie somewhere here. Okay, so this will be this value will be plus 1.96. So anything between this minus 1.96 to plus 1.96 will be accepted. This is the acceptance reason. Okay, and anything outside this frame, if we do not accept on the minus as well as on the right side as well as on the left side, then this is known as two-tailed. This is known as two-tailed. And if we consider only on the one side, then it is known as one-tailed test. Okay, and the value of z differs for one-tailed and two-tailed. If it is two-tailed, then the value of z spans from minus 1.96 to plus 1.96, and outside this frame this will be rejected. If the test statistics after conducting the test, if your value come outside this range, that is from minus 1.96 to plus 1.96, then you are going to reject the null hypothesis at 5% level of significance. Okay, and if we take similarly in this figure as shown here, so similarly here if we take at 1% level of significance, then your this value will be minus 2.58 to plus 2.58, and anything outside this will be considered under the rejection reason, right? Now in case of one tail test and right handed, okay, right tail test, so the values will be on the right side. If it is 5% level of significance, so it will spans from this minus infinity to up to 1.645. So any value on this side will be accepted, and value greater than this, if the z value comes out to be more than 1.645, it will be rejected, because this blue region shows you the reason of rejection. Similarly, at 1% level of significance, this z value is 2.33. And reverse is the case with the left-handed tests. Okay, left-tailed test. Okay, so in this left-tailed test, this z value is in the minus, and if it is minus 1.645, anything on to the left most of this 1.645 will be rejected, which is in the blue region. And in case of at 1% level of significance, it should be less than minus 2.33. Then the your null hypothesis will be rejected. Otherwise, if it is greater than 2.33 minus 2.33, then it will lie in this region, which is the region of acceptance, and your null hypothesis will be accepted. Okay, so now we will be testing our this z test based on different parameters given. Okay, so first will be our this z test based on the population mean. Say for example, we draw a sample from the population and we want to infer that whether this sample has been taken from this population or not. Okay, then we go for this type of test, provided that sample taken from the population should be greater than, its size should be greater than 30. Okay, so now we will be taking up the first case, and that case is nothing but the when we will be testing about the population mean. Okay, so let us discuss now. So now let us discuss the z test for testing the hypothesis or claim about the population mean. Then we will be testing about the population mean. So when the sample size is large, of course, when it will be greater than 30, let the population under study has mean and variance sigma square, where mu is unknown, means we don't know the population mean, and sigma square may be known or may be unknown. That is, you might be knowing the variance or may not be knowing the variance. Okay. So now we will consider both the cases under this heading. Okay. So for testing a hypothesis about population mean, we can draw a random samples. Let us we draw some samples, that x1 sample, x2 sample, xn sample, and where this n is greater than 30 from this population. So as we know that for drawing the inference about the population mean, we generally use the sample mean. And for test statistics, we require the mean and standard error of the sampling distribution of the statistic mean. That is, every sample drawn will be having some mean. So that sampling distribution, which we have already discussed in our last class, okay, that is central limit theorem, I have already told you. Okay, so we will be using that statistics, sampling distribution statistics. Okay, that is what we will be requiring. We will be requiring two things. One will be your mean, okay, and other will be your standard error. And this is of what? This is of sampling distribution with the samples from the population you have drawn. Okay. So here we are considering a large sample. So we know by central limit theorem that the sample mean is asymptomatically normally distributed with mean mu, and variance, what will be the variance? Its variance will be sigma square upon n, and when we square root it, it becomes the standard error. Okay, so this will be this, whether the parent population, and provided that whether the parent population is normal or non-normal. This is what central limit theorem says, and we have seen in our last lecture. So that is x bar, that is the mean of the sample, of a random sample, that will be equal to mu. Okay, this we have studied, and the variance will be equal to sigma square upon n. So the standard error of the mean, sample mean, will be equal to sigma upon root. Okay, so this we know. Now first of all, we have to set up the null hypothesis and alternative hypothesis. Since here we want to test the hypothesis about the population mean. Okay, we want to test the hypothesis about the population mean. So we can take the null and alternative hypothesis like this, that what will be our null hypothesis? Our null hypothesis will be that the sample mean is equal to the population mean, right? And its complement will be that our sample mean is not equal to the population mean. Okay, so our alternative hypothesis is the complement of our null hypothesis, and whenever there is a equality sign is there, if there is a equality sign, this is supposed to be the null hypothesis, and when it is inequality sign, then it is supposed to be your alternative hypothesis. So this is for two-tailed test, when we will be saying that whatever the samples we have drawn from the population, if their mean, the sample of those mean of those samples is equal to the population mean, this is our null hypothesis, and opposite is the alternative hypothesis. And when there is a equality sign, it is nothing but the two-tailed test. So what level of significance and cutoff values we will be using, we have already discussed. So if it is this two-tailed test, then we will be using minus 1.962 plus 1.96. And if it is one tail test, then we will be using in right tail test 1.645 and 2.33, and in case of left tail test we will be using minus 1.645 and minus 2.33. This is at 5%, this is at 1%, right? So now proceeding further, so for one tail test, what can be the your null hypothesis? Okay, so now when we will be discussing about the one tail test, okay, so one is that it is equal, okay, resides in the center. But if I am saying that your sample mean is greater than population mean, then it is going to be right on the right side. Okay, so in that case, say for example, first one we are considering that your sample mean is either equal to or less than. Okay, then what will be your null hypothesis? Your null hypothesis will be, because here equality sign is there, so this is considered to be the your, this is considered as your null hypothesis. And here greater than sign is there, there is no equality sign is there, this is your alternative hypothesis. Okay, reverse of this is that your sample mean is either equal to or greater than population mean, and your alternative hypothesis is that your sample mean is less than your population mean. So for testing this null hypothesis, the test statistics is given by z is equal to this your population mean, okay, minus expectation of your, not population mean, sample mean, expectation of the sample mean divided by the standard error of the sample mean, which is equal to nothing. We have already studied that this expectation of the sample mean is actually nothing but the population mean, and this standard error of the this sample mean is sigma upon root n. So your z is equal to x bar minus mu naught upon sigma upon root n. Okay, fine. Whereas when we were discussing about this normal distribution, this upon root n was not there. Because why this root n came? Because this is the standard error of the sample, not of the population. And in normal distribution, we were discussing about the population. So this root n was not there. Okay. So the sampling distribution of the test statistics now depends on what? It depends on the sigma, isn't it? And that is known or unknown. So there may be different cases may arise. So first case is that your standard deviation, this variance is known. Okay. So in this case, the test statistics follows the normal distribution with mean 0 and variance unity. When the sample size is large, as the population under study is normal or non-normal. Okay. So what we have already studied this thing, that your z variate. Okay. So here also this value corresponds to your normal distribution with mean 0 and standard deviation is 1. Okay. So when it is known, so we can calculate this thing. Okay, now there may be chances that your population variance is not known. Okay, so in that case we will be required to estimate sigma square by the value of the sample given, sample variance given. Okay, so here your sample variance will be equal to nothing but 1 upon n minus 1 sigma I1 to n xi minus x bar whole square. So you can calculate this sample variance using this formula. Okay. Here the difference is that because you are doing the sample statistics, so instead of divided by n, it is divided by n minus 1. Okay. So when the population under study is not normal and the sample size is large, then this test statistics approximately follows the normal distribution with mean 0 and variance d. So this will be the case. Okay. So this will follow the normal distribution with 0 and 1. So after that we calculate the value of test statistics as may be the case. So whether your sigma square, that is variance, is known or unknown, and then we compare whatever the value of this z after putting the value of x, mu naught, s and n is we get some value of z. Then we compare this z value with the critical values. If that this calculated z value is in the region of acceptance region, then we accept our null hypothesis at a given significance alpha. Okay, and if it is outside the region and it is in the rejection region, then we reject it. Okay, so from above discussion what we understood is that when variance is known, then we apply z test as the population under study is normal, whether it is normal or non-normal for a large sample. But when the sample size is small, then we apply Z test only when the population under study is normal. Okay. Then when variance is unknown, then we apply the T test only when the population under study is normal as sample size is large or small. But when the assumption of normality is not fulfilled, the sample size is large, then we go for the Z test. Okay. And when a sample is small and your variance is known or unknown and the form of the population is not known, then we apply the known parametric tests. Okay. So now we will be trying to understand this thing using an example. Okay. So what is this example is, say for example, in a light bulb company claims that 100-watt light bulb it sells has an average life of 1200 hours. Okay, with a standard deviation of 100 hours. Okay, so for testing the claim, 50 new bulbs were selected randomly and allowed to burn out. Okay, the average lifetime of these bulbs was found to be 1180 hours. Okay, so is the company's claim true at 5% level of significance? Okay, so this is we have to test. Company is producing 100-watt bulbs. It is saying that our bulb is having 1200 hours and it is having a standard deviation of 100 hours. Okay, now someone, a researcher or somebody, a inspector, okay, quality check inspector, collected 50 new bulbs, then allowed to burn them out and found that it has the sample of 50 bulbs which it has taken out has a lifetime of 1180 hours. So can we say that the company's claim is true at 5% level of significance? Okay. So here we will try to understand that what these questions tell us and how to crack this question. Okay. So here what is given is that we have a population mean. Okay. And that population mean is mu naught is equal to 1200 hours. Okay. Then we have a population standard deviation, that is sigma is equal to 100. Okay. So these are the two values given, and then we are also having that what that quality inspector has chosen is 50, that is the sample size is 50. So because this sample size is greater than 30, so we will be going for Z test. Okay. So now when he has collected these 50 samples, so what he has observed is that your sample mean came out to be 1180. Okay. So now we have to find out that whether the company claim is correct or not. Okay. So in this example, the population parameter being tested is the population mean. We are testing what we are testing, we are testing the population parameter. And what is that population parameter is, companies claim that its average bulb life is 1200 hours. So our claim is that your mu sample mean is equal to the population mean is equal to 1200 constitutes your null hypothesis. This is your null hypothesis. And why this is a null hypothesis? Because there is a equality sign. Okay. And what will be its complement? That your sample mean is not equal to population mean. Okay. This constitutes your alternative hypothesis. This is what is? This is alternative hypothesis. Okay. So basically, this is what here it is written, that mu is equal to mu naught, means sample mean is equal to the population mean is equal to 1200, average life of bulb is 1200 hours. Whereas your alternative hypothesis is that your sample mean is not equal to 1200, that is average life of the bulb is not 1200 hours. Okay. Also the alternative hypothesis is two-tailed. Here what we are saying, because we are using the two-tail test, equality sign is there, it is not greater than or equal to, company is not claiming that our there is so that we will be taking up. next in next example. Okay, that when we will be using your this two-tailed test. Okay, so we know here that your sample size is greater than 30 50, so we will be going with the z test. So whatever z test says, so let us conduct the test. So z will be equal to your sample mean minus your population mean divided by you have this standard deviation divided by root n, which is equal to nothing but 1180 minus 1200 divided by 100. Okay, this will be root 50. So it comes out to be minus 1.41. Okay, so what is our critical value of this two-tailed 5% level of significance? That is from, it spans from plus 1.96 to minus 1.56. Okay, since the calculated value test statistics z is equal to minus 1.41 is greater than the critical value minus 1.96 and less than the critical value 1.96. It means it resides between minus 1.96 to plus 1.96. That means it lies in the non-rejection region as shown in the figure given below. So we do not reject the null hypothesis. Since the null hypothesis claims, so we support the claim at 5% level of significance. It means that your sample mean is equal to your population. Although it was coming out to be 1180, but still the company claim of 1200 holds valid holds valid for this value of the sample mean. So I will just show you with another point of view. Okay, that is, although your sample mean comes to be 1180, but now we will be finding that how by conducting this z test the claim of 1200 is okay. Why? Okay, at 5% level of significance. So let us see. So this is our this normal distribution. So the rejection region is from below 1.96 and above 1.96, and your value 1 point minus 1.41 resides between this in this acceptance region. So we can say that your claim of company can hold true. If you remember our one of the lecture in which one of the scientists has introduced the concept of confidence interval. Okay, say for example, if we do not have this test and we do not have the concept of normal distribution and we do not have the concept of confidence interval, so these results will be contraindicatory simply. Why? These will be contraindicatory because company is claiming 1200 and when somebody is taking out 50 bulbs, the mean come out to be 1180. In previous lecture, we also have seen that your sample mean may vary from your population mean. But when you will be taking different samples, so ultimately your sample means will follow a normal distribution and the mean of the sample means will be equal to your population mean. Okay, but it will be having some confidence interval. So decision according to confidence interval now we will be taking. So here the test is two-tailed, therefore we contract a two-sided confidence interval for the population. Since the population standard deviation is known, therefore we can use 1 minus alpha into 100% confidence interval. This is nothing but the type 1. Okay, so this will be your acceptance reason. Okay, so it means that what will be the span of your this value. Okay, so whatever the sample you are getting, this 1180 actually have a confidence interval of 95%. If you apply this formula, so it will be 1.96 into 100 upon this root n, and here it will be minus on one side and plus on other side. So you will be getting this 1152.29 and 1207.71. What does this mean? This is very important. You must understand this concept so you will understand all the test. So this sample mean which that uh, quality inspector was telling that it is having 1180. Okay. So if say for example I am taking out the your 50 number of bulbs, say for example many times, okay, so out of 100 you are 95 times, what I'm saying, just try to understand that out of 100 times 95 times your mean will reside between 1152.29 to 1207.71. This is the concept of confidence interval. That is, say for example, from a population which is having 1200 as a population mean, you got a sample of 1180, okay, and it was having a standard deviation. This population 1200, and it was having a standard deviation of 100. You are getting a sample mean of 1180. So your confidence interval will be from 1152.29 to 1207.71. That is, out of 100 times you take the 50 samples, so out of 100 times 95 times your value of your mean will reside between this and this value. Okay, so this is the concept of your confidence interval. So let us now I will show you this with a figure. Okay, so this was your population. Okay, it was having a 1200 as your population mean, and on the either side you are having different values. It was normally distributed. Now you have taken 50 samples out of it. So in this sample, although your mean this will be 1180, okay, 1180, but its confidence is from this 1152.29 to 1207.71. So your value, this 1200, lies between these values, that is 1152.29, this 1152.29, your this 1200 lies in between. So although you were saying your this quality inspector was saying that it was 1180, but it has a confidence between interval between 1152 to 1207, and your 1200, because it lies in between this, so we accept that this value is nothing but is equivalent to your 1200, because this 1200 lies in the confidence interval of this. Okay, confidence interval of this. So hence this is why because of this confidence concept of this confidence interval, we accept this null. Okay, similarly let me do one more example of this thing, then we will close this first session, and then we will join again for our next session. Say for example, a manufacturer of a ballpoint pen claims that a certain pen manufactured by him has a mean writing life of at least 460 A4 size pages. That is, if you start writing with that pen, you can write on 460 pages. Okay, a purchasing agent select a sample of 100 pens and put them on test. Okay, the mean writing life of sample was found to be 453. Okay, it was little bit lower than the 460 with a standard deviation of 20. Okay, so should the purchasing agent reject the manufacturer claim at 1% level of significance? Now it has made somewhat tougher decision, that is, he want a confidence interval of 99% of this manufacturer claims. But here you should understand one thing, that we do not have the population standard deviation. Instead, the standard deviation of the your this sample is given. Okay, so what are the values which are given? So first is population mean is given, which is 460. Okay, other is your sample is of 100, Now this is your example number 2, and your this sample mean is 453. Okay, and your S standard deviation is 25. Okay, so now we want to test the manufacturer claim that the mean writing life, okay, of pen is at least 460. Okay, it should be at least 460. So if it is at least, okay, so then our claim, so our sample should be either be equal to 460 or it should be greater than 460. Okay, and what will be its complement? It will be less than 460. Okay, when a manufacturer is claiming, then we do not want a lot that is having the value lesser than the manufacturer claim, and we should be 99% confident about that. Okay, so basically this because here it is equality sign is there, so this will be our null hypothesis, and this mu, that is sample mean less than 460, that is the claim of the manufacturing company, will be your alternative hypothesis. Okay, so this will be your that your sample mean is greater than or equal to this your population mean, which is 460. Okay, is your null hypothesis, and your sample mean is less than 460 is your alternative hypothesis. So because this n is 100, which is greater than 30, so again we will be applying your this z statistics, but here instead of this sigma, your sample mean will come. So x minus mu naught upon s upon root n. Okay, so your value will be 453 minus 460 divided by 25 divided by root 100. So it comes out to be minus 2.8. Okay, so now because at 1% level of significance, and it is a left sided. Okay, this is a this left tail test. Okay, so your this z alpha should be equal to minus 2.33. So your critical value is 2.33 minus 2.33, and your calculated value is coming out to be minus 2.8, and which lies in your rejection region. So at 1% level of significance, the purchaser can reject the company's claim that it this pen can write the 460 A4 pages. Okay, so this is how we do this test. Okay, so in the next session, which will we will be starting at around uh, 4 o'clock. Okay, 15 minutes after this. So at 4 o'clock we will again be rejoining with the rest of the topic of this lecture. So this is all for this lecture, and as I can see that there are no questions from the student side, so I am stopping this lecture here. So thank you very much. Thanks.